And now we have 5-point graphing method. Here's the steps that we went through in class. I kind of included some more detail here in the video lesson, because I'm not there to explain the step-by-step to you, right? But this is good refresher. These are things you should be watching before quizzes and tests. But here's the steps to graph in the 5-point graphing method. I'm not going to read through all of them right now, but you'll be able to see them in action as we plot some graphs. This is from the last video in case you didn't get it or didn't watch it. Here are what each of these shifts and transformations mean. I also named them by name: amplitude, frequency, phase shift, vertical shift. Sometimes you have vertical shift called vertical displacement because you're actually moving the whole graph. Okay, let's try a couple of these. So first step is always going to be to label, all of your transformations. So A is 2. B in this case is the number in front of the x, which in this case is 1. H is right pi over 3. And our K is up 4. Now, to find the period, remember we use the equation P times B equals 2 pi. So in this case, my B is 1, so my period ends up being just 2 pi. The second step is to determine what to count by on the x-axis. And how we're doing that is by using our H and our B. Now in this case, our B is just 1, so it doesn't play a factor in this. Okay, but our H is 3. We want to count by something for pi that's a multiple of 3. 4 is the minimum though, so the first multiple of 3 bigger than 4 would be 6. So we're going to let 1 pi equal 6 blocks. And then I label my x-axis. So here's a pi, here's a 2 pi. Okay? Now what I want to do probably before I start is translate some of these things to blocks. So a right shift of pi over 3, 6 divided by 3 is 2. So this is actually a right shift of 2 blocks. And if my period is 2 pi and pi is 6, that means my period is actually 12 blocks. And that just helps as I go through the process. All right, next step will be to plot my vertical shift of up 4. I represent that with a dashed line. That's sort of like a new x-axis. Okay, that's going to represent my new center line for my curve. And right pi over 3, we said that's 2 blocks. So you see the advantages of labeling these in blocks. Just makes the process a little bit easier. And now I'm graphing sine. So remember my points for sine are intercept, max, intercept, min, intercept. Right? 1, 2, 3, 4, 5. The order I'm plotting them in though is 1, 5, 3, 2, 4. Okay, so point 1 is an intercept. That is the intercept of those two shifts. Point 5 is next. That is 1 period away. 1 period is 12 blocks or 2 pi. So I go 12 blocks away and plot my last point. Okay, my third point is halfway between those two. So halfway between here and here is 6 blocks. And that's still another intercept. Okay, and then my second point is halfway between these two, and that's a maximum because it's a positive sine curve. And that maximum comes from here. The amplitude is how we get our max and our min. Okay, so my max of 2, halfway here, my min of 2, and I can draw my curve. Put arrows on the end because it does continue forever. So really, the key idea here that you need to remember is that the horizontal and vertical shift, we do the dashed lines with those, and then we're done with them. They do not come up in the rest of the plotting of the curve. That's why I teach it that way, because that way you can take care of those and then move on to the other things that you're trying to plot, and not have to worry about negotiating all of those shifts at the same time. Let's try another one. 4 cosine x plus pi over 4 minus 1. Notice again here we have no frequency change. We will do a frequency change together. Okay, let's see here. H is going to be left pi over 4. Okay, and then K is down 1. All right, period is 2 pi again because my frequency is 1. Relate this to blocks. The minimum is 4, and my x-axis has to be a multiple of 4. So 4 is a multiple of 4, so we're going to let pi be 4 blocks. All right, frequency didn't play a factor there because it's 1. So I let every 4 blocks be a pi. Okay. And now I start talking about my shifts. So pi over 4 would be 1 block. okay, because it's easier to count blocks. 2 pi would be 8 blocks for my period. I'm talking about cosine. So my 5 points in the 5-point graphing method now are max, intercept, min, intercept, max. All right, but I want to plot my shifts first. So down 1, that's an easy one. Okay, and then left pi over 4, so that's 1 block to the left. And now I'm ready to plot my cosine curve. Remember that when I'm talking maxes and mins, it's all based off of this dashed line and this origin, okay? So when I plot that first max for cosine, that maximum comes from the amplitude. So I need to go 4 above the origin, right? So 1, 2, 3, 4, that's my first point. My last point is also a max, okay? It's 8 blocks away, all right? That's here. Okay, so cosine's a little different. Now, halfway between these 2 points, okay, is the min. But the min is not on the dashed line. The min is below the dashed line. 4. All right, and now my second and my fourth points are going to be intercepts. So now I'm going to plot some points on the dashed line here and here. There's a tendency to make this a V. Just give it some curve. I realize the more narrow it is, the easier it is to fall into that trap. But we want to try to give it as much, curve as we. Okay, it would help if I could count over here. That point should be there, not there. Okay, but try to give it as much curve as we can. And remember that these maxes are just that. They're maxes. Don't continue this line up here. It has to come up and then go back down. That's your cosine curve. Now for a frequency change. Let's see what this looks like, and then we're going to call it a day. So amplitude is -3, -2. Okay, now we have a frequency change of 4. We have a horizontal shift of right pi over 6. We have a vertical shift of down 2. Okay, we don't know the period. We got to find it this time. So PB equals 2 pi. So P times 4 equals 2 pi, which means my period is going to be, divide by 4, pi over 2. Okay, so my period is pi over 2. All right, now, when I label my x-axis, I'm trying to find the LCM, the least common multiple of 6 and 2. Okay? So if I do that, I would say that the LCM there is just 6. So I'm going to let 1 pi equal 6 blocks. Okay? So here's a pi. Here's a 2 pi. Okay? Now, vertical shift down 2. Horizontal shift right pi over 6. But, I forgot to count my blocks here. Sorry about that. So if 1 pi is 6 blocks, a right shift of 6 over 6 is 1 block. Okay, and if my period is pi over 2, then let's see here. 6 divided by 2 is 3 blocks. So 3 blocks will be my period. Ooh, that's going to really crunch things down here. Okay, so right 1 block for my horizontal shift. My first point is here. Now my last point ends up being just 3 blocks away. So I will end up plotting some half points here. That is what it is. Okay, so halfway between these 2 points is going to be my other intercept. The halfway marks will be my maxes and mins. It's negative, so that's going to be a min first, and then a max here. And things are really scrunched down now because it's been compressed so much. All right, and I can plot this as many times as I'd like. I just continue that process, 3 blocks away, halfway, okay, min first because it's negative, max second, and curve. And I can keep doing that as many times as I like to get my curve.